Alright, so let's go over your homework. Page 445. I asked you to do a few of these problems here, so we'll take a look. 445, number 11. Alright, so number 11. Let me see here. 11 looks like this. It says x squared minus 36y squared equals 36. We could divide everything by 36 to get the 1. And then from here it's pretty easy. This looks like it's horizontal because the x comes first. We know that a squared is 36, so a is 6 and b is 1. And then let's see what else here. It's asking us to find the foci, slopes of the asymptotes. Alright, so because it's horizontal, that means it's going to look something like this. This is A and this is B. Well, if A is 6 and B is 1, the slope of the asymptotes would be plus or minus 1 over 6. And what else do they want us to find? The coordinates of the vertices. Okay, well the vertices are right here. So if the center is 0, 0, the vertices, or the endpoints of the transverse, would be 0 plus or minus 6, comma 0, or you could just write plus or minus 6, that's fine. And it wants to know the foci. Okay, well, we know that A is 6 and B is 1, so if C squared is equal to A squared plus B squared, 36 plus 1 is 37. So C would equal square root of 37. And that would be on this axis. So we're going left and right. So we start at the center, 0, 0. And we would just go left and right radical 37 units, something like that. All right, let's do one a little bit more interesting here. Number 15. Number 15, it says that hyperbola is centered at the origin, okay? With a horizontal transverse axis. So that means that x is going to come first, and then y. The value of a is 1, so a squared, and the value of b is 4. Okay, well that's pretty easy. I thought that'd be a little bit more entertaining. So that was that. Let's take a look at number 19. Problem number 19 is pretty standard stuff. 21 is the same. 29 looks good, and 37. Okay, so we'll do 29 and 37. For problem number 29, it says we have x plus 1 squared over 4 minus y plus 3 squared over 9 is equal to 1. So it looks like we have another horizontal. A squared would be 4, so a is 2. B squared would be 9, so b is 3. Our center would be negative 1 comma negative 3. Because it's horizontal, we're going 2 units this way, 2 units this way, and then we have our branches. B goes 3 units up and 3 units down, the opposite direction. I mean, if we wanted to make this more precise, we could box them in and draw our asymptotes. Something like that. Alright, and what's it asking us to find here? Find the coordinates of the vertices, okay? So from our center, vertices are going left and right. So we're going to be adding and subtracting the a value to the x. Give us these right here. The foci, well, we got the foci. We have to remember that c squared is equal to a squared plus b squared. 4 plus 9 is 10. Taylor-Swift's favorite number, which is 13. So C would be root 13, and that would be along the x-axis. So we're going root 13 units left and right from the center. Slopes of the asymptotes. Well, just look at your picture. We go up and down 3 over 2. And then draw it. Okay, so that's what they want you to do for number 29. One more here, we'll do 37. 37, it says the vertices of the hyperbola are -5 and 5, 0. And those are vertices, which means it looks like this. So automatically we know it's horizontal. We know that A is 5. The conjugate axis has a length of 12, so that means that it goes up 6 and down 6. Because the length of the conjugate is 2b, and that's 12, that means that b is 6. So b squared is 36. And as far as the center, well, if you take the center of the vertices, you get 0, 0. So that's why that's the equation for number 37. Okay, so stay tuned for today's lesson.